Hey everybody, this is Rydo and we're back to Human Resource Machine. Let us continue. So, I've been talking a lot about programming up until this point, and I will continue to talk a lot about programming. But it's worth pointing out, I'm not talking a lot about games, or video games. And there's reasons for that. The gameplay elements on this are almost non-existent. You could, at best, call this a puzzle game, and the puzzle is to find the solution. But it's a very open-ended puzzle game with no real direction. It's like a jigsaw puzzle with no interlocking joints and extra pieces, and oh by the way, you have to make the pieces yourself, and oh by the way, there's no picture on the puzzle either. It's just a blank slate. It's a very odd attempt to gamify programming. Big changes are coming, he says, but I see that you already know that. Yes, you can now access slots on the floor indirectly. This is a big change and will help a lot. And unfortunately, you don't ever get to use it in any of the previous programs, which would help you actually speed up or at least make more robust or efficient some of the programs. What does that mean? You will see. It's going to change everything. Imagine each thing in the inbox is an address, and each address refers to a tile 0 through 9. For each address in the inbox, pick up the letter at the address and outbox it. Congratulations, you can now access tiles on the floor indirectly. Observe the example to see how it works. So instead of copying from, this will still copy from 12, the number 8, but then this will copy the letter Y. Watch. It points. So, how you get indirectly, you have now this little toggle you can use. Tell me more. Management would like to thank you for your efforts. Notice I'm also white-haired now. Indirectly. Through me. Little indirectly joke. If your inbox is 1, well then 1 would be K. 1 would be K. 5, which would be D. 4, which would be R. And 1, K. You would outbox KKDRK. Optimization challenge, 5 or fewer challenge commands. This is actually rather easy. Simple program here, shouldn't have any trouble. Copy to, let's say 10. We don't have to use 12, we can leave that 8 alone in case we ever need it in the future. And then copy to 10, copy indirectly from 10, and outbox, and jump. And that's all we need to do. Of course, I guess you need this, don't you? If you don't grasp this concept, then it's kind of pointless to go to any future programs, because you won't be able to program them at all. Puts down a 5, that points to the 5, to the D, and outputs the D. This puts down a 7, points to the L, puts that out. Sometimes this spells out a word, D-L-A, 2, we'll give another A, and 9 will give us J. So no word really, D-L-A-A-J. So we get a simple puzzle, that's good. 5 commands were used. Did we do less than 25 steps? No, but we did 25, so we're done. So, yeah, if you couldn't do 29, if you didn't grasp that concept, this indirect concept, which we've got some pictures here on the side, kind of pointing to some things, like size and speed challenges, the little green lights, and A, B, C edition here, which I believe was, which one was edition? Rainy summer, perhaps? And then welcome employees. This is the elevator, by the way. What kind of elevator has buttons laid out like this? Yeah, that didn't make any sense. It would be kind of funny if at the end you could scroll way up and there's an extra button. That was the end of World of Goo, but I didn't see anything. Well, I guess I'll check again when we get to the end. So, next assignment, special covert assignment. Management is requesting strings from the floor. Let's just process the strings and not read or discuss what they say. It would be impolite to read messages intended for someone else. And forbidden. For each thing in the inbox is an address to a tile on the floor. For each address provided in the inbox outbox, the requested item from the floor, and all the following items on the floor until you reach A0. So, we have 24, well 25 because it starts at 0. 25 squares, we only have one that we can use, so that needs to be copied to this to start off with. And we could type ref here just in case if we needed it. We don't need it though. Tell me more. Well, yes, I went on a date once, but I was told my heart was an encrypted vault of solitude. I assumed it was a compliment. We never saw each other again. So, this potentially could be a example of compression. Not really encryption, but what you could say is this is a compression dictionary where the word get, G-E-T, for example, might be used in several occurrences, so then the rest of the file might have address pointers like these to say, well, the word get belongs here, but since it's used in several places, you can refer back to the beginning. So what we'll do is we'll copy to reference, then copy from reference, and then outbox, and then we will simply bump the reference and jump back to this point, and then we will have a jump of 0 when we copy from reference if it's a 0 to get out of that cycle, and out of that cycle should just need to point us back to the inbox to get the next address. So that's 7. What's the optimization challenge? 7 or fewer, or 203 or fewer steps. Give me an example. If your inbox is 7, you would send tar. 7 is tar, T-A-R 0. So I think we're done. It's just a slight addition to what we learned in the last program, and the last program wasn't that hard. So we have TH, and then the next thing is 15, which gives us the letter E. So V, and then 0, and then 7 here, T, A, R, then another 0, and then this one refers to 0, so G-E-T, the target, This is more of that subtle background story of, is this corporation we're working for actually very evil and helping the robots? So we know the target is the first two words. X, what can you spell with X? Not much. But it could be stop, like if you were sending it via telegram. Is, the target stop is, or target X is. A-W-A-K-E, awake. So let's see the full output here, because this is actually slightly interesting. We could watch the code as it follows. I imagine if anybody's followed me this far into the series, they're at least slightly understanding what's going on. The target is awake with another X, and then another X, and then another X. I suppose it would be possible somebody was trying to watch this while still not understanding it. I'm sorry if you're going through that. I mean, I applaud your efforts. Maybe this will help ignite some interest in learning if you are that viewer in learning programming, and maybe you'll go to a real resource. I would probably recommend Khan Academy might be a good place to start. There's also several other people. Take is what the next word is. Take the take this I would recommend what you would want to do if you want to program something. Learn HTML first, and that way it'll be one of the least connected programming languages that you'll learn before you move on to something along C++, C#, G#, Java. I don't know if you should really program in Java these days, but you very well might need to learn it. All of those languages have some distinct differences, but HTML is designed just to make web pages, so it's lighter on complicated math manipulation than anything else. And then I'd say in the HTML class you'll probably learn a little bit of JavaScript, and that JavaScript will introduce more of the complicated math programs here. And by learning those first, you can then quickly kind of forget HTML and JavaScript because they're kind of simplistic and not very useful languages, but have been through the process once before you start something more difficult. If you jump straight into Java, if you jump straight into C++, you can do it certainly, but then if you're doing this for a degree or for high school, they're probably going to want you to go learn HTML anyways, and then you're going from something very difficult to very easy, but it would actually make it a little bit more difficult to learn HTML, in my opinion, after you already know C++ or any other language. Hello, written backwards. How are you today? Haha. Okay, now seriously. For each zero terminated string in the inbox, reverse it and put the result in the outbox. Repeat. This is actually an incredibly easy thing, but tell me more first. a man, a plan, a pan, and a lamp. Did I tell you about the time I went to Panama? It was a long time ago. Or maybe it hasn't happened yet. I get the order of things flipped around sometimes. So, let's see an example here. If your inbox is mini lake alive, you should send out MANY backwards, YNAMY, EKAEAL, which is lake backwards, and then LEVILA, which is alive backwards. What's our optimization challenge here? 11 or fewer commands. I don't need even 11, I don't think. Inbox copy to this pointer here, right? So we started 0 here, and I'm just going to call it pointer. I'll use probably the phrase pointer a lot. And pointers are just reference numbers, but I like to call them pointers. Same thing. It's going to point to here, and then I'm going to bump this up 1, and then jump if 0 if the inbox comes out, and otherwise keep putting it in here. This program will work fine as long as they don't give me anything bigger than 14 spaces, 0 through 13. If they give me more than that, you would potentially have a buffer overflow attack, because the buffer, which is what the tiles on the carpets are being used as, you'd be trying to access memory above that, the registered amount of memory, which is how many tiles you have. You can also have a buffer underflow attack, where you would try to reference something below the buffer, although typically most of the time you'll hear buffer overflow. You'll sometimes even see it in crashes of programs. If Windows crashes, it may say buffer overflow at memory register something something something. Not that that information is really going to help you any at all. Pretty much what you see when Windows crashes is useless information. Never gonna help one bit. So I'm gonna put a jump of negative here, and then I'm going to put a jump here. So this is the output. I'll just put out, and this is the in. So it's going to get something from the inbox. If it's 0, it's going to jump to this point and go to the output loop. Otherwise, it's just going to stay in this input loop, which is going to grab something from the inbox, copy it to the referenced number pointer. So it'll start at 0, and then it's going to bump it up by 1. So it will change to 1 the second time it's through the loop, and put the second letter here. It'll change to 2 the third time it's through the loop, and put the third letter here, and it will just keep doing that until it hits 0, and then you'll have this number, which is 0 at 3 when it enters the output loop. So what does it do then? Well, it simply at that point will copy from the pointer. Instead of copy to the pointer, it will copy from it and output it, and then it will bump the pointer down 1. So it will grab 3 and output it, bump it down 1, grab 1 and output it. It will grab 2, then it will grab 1 and output it, and then it will grab 0 and output it. If that makes sense. I said that wrong. I said it would grab 3. It won't grab 3. It will grab 2, output it, bump it down, 1, output it, bump it down, 0, output it, bump it down. When it bumps it down to a negative 1, it jumps from that point to here, which is a slight issue, because as it runs we'll have a buffer underflow, because this will be at negative and that will not work. Let's hit play and show it, because there's an achievement for doing a buffer overflow or overflow here, address not reachable things. So HER gets us to this point, sees the 0, and empty value from copy from doesn't work. So let's put the bump negative here and then jump if negative and move things around a little bit. Try that again. So we'll bump it down once because it needs to do that. We still have that same buffer underflow issue occur, though. We need to adjust for that, and that can easily be done. We just need to bump the pointer back to 0. So we've got logic here. We hit the 0, and then we bump it down and send it backwards. So G, then O, then L. Notice the O here and the 0, exact same design. Not what you want in programming at all. You want a dot in the 0, a slash through the 0, something that makes it apparently logic, or an O that's very wide. So here's your bad tile address with the address of -1 does not exist. Where do you even think you're going? Alright. So now I have to hit stop to make a change. You take this, and instead of jumping up, we simply bump the point at 1, because we always know it will reach this at -1. Because we're only ever bumping it down 1 in there. That puts us at 12 lines of code. We want 11 or fewer. So what could we remove? What could we remove? Jump if negative's necessary. This jump is necessary. This is necessary. This jump is necessary. Let's hit play and think about it for a second. Up, UP, space, jump of 0, bump down, this becomes PU. What is the one step I don't need to actually take? Well, I think what you need to do is I need to move this up a little bit to 1. And then put the bump plus. Oh, all I have to do is actually jump right here. If negative, jump to this bump plus, then he'll jump to the inbox and be fine. So let's speed this up. As we can see, it's working. And you certainly should feel satisfied in just getting it to work at all. And that's 123 steps. So if we instead jump to this point, remove this, and remove this, we're down to 10, which gets us 1 less. Let's hit play. We're simply reusing this bump plus as a good reuse. This again is kind of bad programming, I would say. Trying to save space by having the program jump into a ridiculous point doesn't make sense. So that gets us below 10. Now let's just save ourselves some space. We need 1 fewer step. Is it something along the lines of this? I don't think so. See pointer plus, nope. I think the easiest thing to do again would simply be add an inbox, do a jump of 0, copy to the pointer, reference that, bump up the pointer, and keep doing that until it's done, and then bump down the pointer, copy from the pointer. I did start just saying it was incredibly easy, but it's complicated. It's not difficult beyond its complications, it's just difficult because of them. And this jump here goes back to the beginning, which potentially I don't need, but whatever. Actually I do need it. And this jump, if negative, when we read the bump down, needs to go to the bump plus. There. Let's see. This then goes through this, and bumps up to this. Which is not what we particularly want. We want this one. I don't think this saves me any steps. I don't think this program doubling out saves me anything. In fact, it causes errors. Let's try that again. Maybe things are backwards. So yeah, I'm not sensing a way for this to be helpful. Copy to pointer. Bump it up. I suppose you could probably assume that you're always going to get at least 2 inputs, but I don't see how that would help me. See, if you bump up the pointer like that, then you're just going to put the number you had there. Inbox. Copy the pointer if it's 0. Then bump that up, and then keep on inboxing that, and then copy from the pointer and then outbox, and we could negatively affect that. Let's go ahead and just get rid of the double code for the moment. Double check to make sure this works. If anything, this is the exact same code we had before. One step. Perhaps if we, instead of jumping here, did a jump of 0 here, and then copied from the pointer. I mean, well, actually, we don't even need to copy from the pointer. We can just copy from 0 and outbox, and then jump. Let's see if that lowers the... Well, that doesn't... Did I move that? I think I may have moved that. Will this save us the one step we need? I mean, we could try other tricks to make this faster. But if it's not the one you care about, it's not the one you care about. Yeah, so that's in me 11 steps. I'm satisfied with that. Move on to the next thing. I'm glad I'm making quicker progress progress here than I thought. I honestly believed that we may go like 30 episodes, which would have been rather long and boring. Inventory report is an interesting one that I'll show you a solution I came up for it later, but let's start with what we have here. Inventory check, accounting verification, surprise audit. There are a few of these are a few of my favorite things. So let's get started. For each thing in the inbox, send to the outbox a total number of matching items on the floor. Tell me more. There's an achievement for clicking tell me more on every single character, by the way. How can you determine if two letters are equal? Maybe try the same thing you would do if they were numbers. Yes, B is just one more than A. You made it this far. I'm sure you already knew that. Give me an example. If your inbox is X, send a 3 because there's 3 X's in here. I can't even see them all. 1, 2, 3. If your inbox was C, send out 2 because there's only 2 C's. And if there's an X, send out 3. And if there's a B, send out 5. If there's an A, send out 4. Pretty easy. What's our optimization challenge? 16 or fewer codes and 393 or fewer steps. So the one thing that's different about a letter is you cannot put a number and a letter together, which is unfortunate in this program. There would be ways to do it in most programs. So when I get an inbox and I subtract this C from this B, I will get a number, and I won't be able to then just add it back to that to get the letter, because that wouldn't make any sense. So instead I have to put it in a letter slot to keep that combination if I needed the letter again. In this case, I don't think I actually need the letter again. So we take the C, put it here, subtract here, it gives us 1. And then it says you can't add with a letter. What would that even mean? Well, what it would mean, obviously, is if you added 1 to B, you should get C. And yet this program is not verbose enough to do that. So all we need to know is if it's 0. If it's 0, bump this number here, and we will start by copying this to this, and we'll call this count. Wish I could just type. It's so bad. Wish I could just count. And then copy from this to outbox it. That's the last thing we'll do. This will be the very last thing we do. So we've almost got it. We just now need to not subtract from 0, instead subtract from what we'll call the pointer. And we will copy a 0 to the pointer, and instead of copying from the letter and subtracting the pointer, we will copy from the pointer and subtract to the letter, which is not a relative value, that's always going to be that. If it's 0, we know to bump the count, otherwise we're just going to bump the pointer and jump from this point to here. So that's 14 lines of code. How many do we need? 16? I think we're done. Let's see. So we're going to do a little setup. We're going to take 0, put it here, here. Take the A here and put it there. Take this, subtract, it's not a 0, so we know it's not a match. Take the next one, subtract, it is a 0, so we know that's a match. And we've got a couple of problems there. Bump the count. Let's see. This here needs to be copy from the pointer if that's 0, this 0. So when it gets up to this point, it needs to do that. But if it doesn't, it needs to just go back up to this cycle again. There we go. So there's a double loop here going around, making quite the mess of jumps, which is awful. Again, you're really not learning at all how you would program not using loops, not using jumps. And you rarely do use loops. Well, you use them a lot in programming, but not as much as this is. This is a ridiculous amount. There's also a form of testing things called switch statements that would work rather nicely in this example, where you would say letter, switch, and then you would define a case for the letter B. You would type in the phrase case B, and then you would add to the count when that matches a B count. Case C, you'd add to a C count, case D, E, and F, and just so on and so on and so on. And in that way of using the switch statement, you could potentially count all of the letters immediately and store all the results easier. In this simplistic example, though, it's not really necessary. So we subscribe, we bump count, and I need to actually bump the pointer too. So this jump doesn't go here, it actually goes here. Just making it even more confusing. Put a 0 here, put a 0 here, get the letter, stick it here. Grab this one, subtract. Add the pointer up because it doesn't match. Grab this one, subtract. You get 0, so add the count and add the pointer now and grab this. Subtract and do this. So we've got the solution down. Let's go ahead and just skip it to the end. So it's using this 0 as a 0 terminated string. Effectively, this is a 0 terminated string to tell it to stop going any further after it hits 14. That actually adds some steps into it where you would not probably beat the steps program, the steps challenge doing this. It adds at least one step for each input, possibly an entire loop. How long a loop is depends on the code you wrote. But it does get it done in 16, and I'm only 14 steps away from that. So how would I reduce the number of steps here? Copy from this to count and pointer. I still think we'd probably need that. Copy to letter on the inbox. Need to do that. Copy from pointer, jump of 0 to this point. Copy from count to inbox. Subtract letter, jump of 0, bump, bump, bump. This seems like a pretty simplistic code, so the best thing I could think to do would simply be just duplicate it as we have so many other times as our way of cheating the system and lowering the number of steps. Pointer, copy from pointer, jump if 0. Let's see, subtract letter, bump pointer, bump count, pointer, bump count. Some of these jumps are in the wrong places, I know. Jump, copy from count, and outbox. So that's the dividing line there for doubling this up. Inbox, copy to letter, copy from pointer. If it's 0, it should then copy from count. If we subtract the letter and it's negative, no, if it's 0, then we bump the count, and then we jump that bump the count back to copy from pointer. How does this work? Bump pointer. Yeah, so the jump after we bump the count is right in front of pointer. And then there should be a second jump under pointer that goes to this point. And the only escape is this jump if 0. Not that jump if 0, this jump if 0 here. Play. And fast forward, and we'll see if that got us down enough to beat the speed test. And even if it doesn't get us the speed test, because I want to talk about a different way to do this than that you would definitely consider when writing your program, that's much more interesting, and I'll certainly go get that code and bring it over to this. So when you program for any program, if you at all can know your inputs and optimize for your inputs, you probably should, unless you're just trying to make a robust program that may have any inputs. There are actually some limitations. If you know, for instance, that the number that can be inputted on the computer is only going to be up to 100, then you can make a program that's a lot faster than that by working around that and not looking at the thousands number digit if that's something you want. Now, of course, maybe 50 years down the line you have a Y2K issue because of that, and that's what they certainly did in the Y2K bug, is you certainly had this issue of let's see, inventory report. This is it, right? Or is this it? Or is this it? Maybe none of these are it. Maybe this isn't the one I would do. So what you could do here is you can sort. Let's see if this is the one that sorts. And then you can make assumptions because of your sort. If you took this program and put all the A's at the front, then instead of having to go through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14 inputs, you could say, well, I'm looking at the A's. When I see a B, I'm done. So you go 1, 2, 3, 4. I'm done because there's only 1, 2, 3, 4 A's. Well, so you go 1, 2, 3, 4, 5, and then be done. That's not what this program is. So this is just the first time I did it. Similarly to how you saw, and probably doesn't beat the code in speed. I would imagine the code I want to talk about is the third one, not because I numbered them. So hurry up, program. Let's see what we get with this result. It's almost exactly the same code here to what I just built. And that's not because I'm boring, it's just because there's only so many ways you can skin a cat, and whoever would want to skin a cat, I don't know, but there are only so many ways. So, same thing, same issue as before. So then 2, we have length, we have end of line, we have count, length, and pointer. I put EOL here as the end of line marker, and let's see what this does. This instead is counting up to the length of letters, and then, oh, let's slow down and show. When it sees all those letters, it takes one out, thus making the length a little bit longer, shorter each time. So instead of having to look at the 14 number, it just has to now look at the 12 string. And how did it do that? Well, it took out all the C's. Look, if you notice, there are no C's here anymore. So that, by making your data, making your reference table here shorter, that works, except for in the case where there would be a second C. But if you're doing inventory, why would you need to tell them twice what all the C's were? No point. So let's go through the cycle again a little bit here. And now it's going to take out all the X's. Every time it finds a match, it's going to take something from the end, see if it's a match, and put it in the space where the last match was. And then it copies a 0 for end of line and puts it in the same place. So that is certainly more helpful. Let's see where that code gets us as far as when it's done. Having just to search through the list that's a little bit shorter each time is going to save us several steps. Even though we are taking a lot more steps to move things around. Notice all the B's are going away here. And just the A's are, well, all the A's are going away actually. So a lot less to work with after that. 36 lines of code to do that, not slightly different. Unfortunately, not great at a speed challenge either. So that's a good example of adding steps thinking you're going to make it better, and I just sat there for 5 minutes talking about how it was better, and it isn't. Let's hit this one now. This one's going to copy 0, put it here, here, and then type this in, and then see this, and this. This, and this. I could have sworn one of my codes was to speed this up, was to sort things around. But it doesn't seem like that's what this program is programmed to do either. Maybe it's a different program that we will see later on. Almost certainly if you did sort this would save you time. But maybe in this one occasion that's not actually true. All this is doing is the same thing we saw before, and yet there's something here that I managed to do that sped it up, I hope. Otherwise, I don't have the code that I used to speed it up. I'm noticing a bump of 1 and a bump of the pointer. That's supposed to be a P here. Let's speed this forward. Let's just speed this forward and see how this code reveals. Well, that's a shame, and it goes to show how easy it is for me, at least, to forget the code I wrote for specific programs. You will get to see that program that sorts, but obviously it's not this one. This seems to do it the same way, but I must have just manipulated one jump or one thing to get it under the speed challenge. 17 steps gets it right at the speed challenge. So let's go ahead and copy that, exit back to the menu. Well, I certainly hyped that up and am eating crow now. Let's see. Inventory report. And then paste. So we copy from 0 and we put it on pointer and 1. We copy to the reference from the inbox, then we copy from the pointer, jump of 0, subtract the reference, jump of 0, bump up the pointer, bump up 1 and the pointer, jump this way, back to this to copy from the pointer. Here we would also and then copy from the pointer and copy from 1 and do it. So what's the one thing that's different here is this is not there. Jump of 0, pump up this and this. This allows me to then save a step to go here and then simply get rid of all the duplicate code here. So in eliminating the jump here that I was trying to be cutesy with, I fixed that. And pointer and counters, that's the same. We have pointer and 1. Yep. So, best as I can tell, that's it for what I need. So let's hit play this time and see if that fixes it. And if it doesn't fix it, then there's obviously one little piece of code that's off, and I'll just run the other one and get the challenge done. Unfortunately, that is the bane of all programming, is one little command in the wrong place, typed the wrong way, crashes the entire system. Every single cog in the machine has to be perfectly made. You cannot make any mistakes at all. Programming is a game of perfection. 100%. There is no such thing as close enough. There is no such thing as I almost have it working. Either it works or it doesn't. And we got it. So, let's see where's Carol, and then we'll be done for this recording. It's sunny outside and the power's back on.
Hey, where's Carol? Oh my god. This coffee is amazing. Back to work, ladies.
See, the power had to be on.
Breaking. Previous reports of machine army evaluate to false. Everything equals 100% fine. Whether within pleasant tolerance parameters or human skin layer, you're all going to be fine.
So again, we get that backstory. Maybe this corporation we're working for is running the robots and all of that. Or maybe this corporation is just oblivious to everything that's happening. We have 34, 35, 36, 37, 38, 39, 40, 41 to do, and then this is just credits. So, making a lot faster progress than I had hoped. It may very well be that we spend 7 more hours doing these last 7 ones, but I'm kind of breezing through everything. Thankfully, because I spent a week playing this game before, which is certainly strange. Strange way to review a video game, to play it once and then play it again. Anywho, that's going to be it for this recording. As always, I ask you to like, share, subscribe, comment if you want to, and watch every second of my videos. All of that helps me out. If you want to support me further, you can click on my name, Rydo. On the right will be a blue button that says support this channel. Click it, make a donation. And if you want to friend or follow me on basically any social media sites, there's a whole bunch of links down below. Thank you for watching. Have a good evening.